Next, to start the formal program, it's always a great honor to introduce Professor Suzanne Berger, who's an Institute Professor of Political Science at MIT. Institute Professor is the highest rank among all faculty, and Suzanne is truly a legend. She's also the co-director of manufacturing at MIT with me, and it's such an honor to work together with Suzanne on building all these efforts. Suzanne's distinguished career includes many things, such as leadership of the MIT Production and the Innovation Economy study, which published a couple books around 2013, a landmark study on the connection between innovation and production. And earlier in her career, Suzanne created the MIT International Science and Technology Initiative called MISTY. If you're on campus, you know MISTY very well because it allows students and faculty to collaborate with others in dozens of countries around the world and sends hundreds of students to do internships in laboratories and companies worldwide. So Suzanne has been leading us in thinking through and now launching this large new research project that we call New Manufacturing, and that's an output of nearly a year and a half of discussions among faculty and students, and I'll turn it over to Suzanne to tell us about it.
Thank you. Good morning. I'd like to talk this morning about the symposium this year. We're calling it New Manufacturing and Scale Up. And by new manufacturing, we mean manufacturing that has certain objectives. The objectives are manufacturing that's more productive, more resilient, less carbon intensive, and that has better jobs than the jobs that we find in most manufacturing companies today. And we call firms that excel in reaching these objectives new manufacturing. And that's whether they're new startups or whether they're three-generation-old firms. So we define new manufacturing by the objectives that these companies are focusing on. And we have a group of MIT engineers and social scientists that have come together over the past year to figure out how we get to new manufacturing. And that's what I'd like to talk about this morning. I think we're at a major historic turning point. Our government and governments all around the world are directing tremendous new resources to manufacturing. And it's national security that's driving these resources. We see massive new subsidies, we see new tariffs, and new controls at the border. And I think we have to understand that it's the risk of war with China, it's the reality of war in Europe that's forcing us to limit our external dependencies. We have 3 decades of peak globalization, and that's over now. COVID taught us that resilience has to be a critical public good. The mantras of lean production that we all swore by for 30 years, zero inventory, just-in-time production, those mantras look a little shop-beaten, look a little worn they look different after COVID, because COVID has led us to rethink whether zero inventory and just-in-time production are really the goals we ought to be aiming for. I think we've also learned that we can't focus only on the leading OEMs in the defense economy, but we need to bring up the whole industrial defense base. And as we've discovered in our MIT research, in fact, most SMEs, most firms that have fewer than 500 employees do have a defense contract from time to time. And so that means that, in fact, all these US manufacturers with fewer than 500 workers are, in fact, the defense industrial base. I think we've also learned, and if you've been in Cambridge or Boston over the past summer, or in California, we've learned that the climate challenge is today, not in some hazy, far-off future. And finally, that if we don't create better jobs in manufacturing now, there are going to be fewer and fewer candidates to fill these positions. And I think perhaps the most important of the lessons that we've learned over the past 10 years is 10 years ago, you could have people like the economist Larry Summers argue that we don't need manufacturing anymore, that it's just like agriculture. We could run down to having 1-2% of the population doing it, and we could draw on the world's resources for manufacturing. Today, we don't hear that claim anymore. I think across all partisan lines, people today have come to understand that manufacturing is critical to innovation. It is critical to the strength of the economy and the strength of our national security. And I think there's also a moral or a cultural point here. It's what Americans think our society ought to be doing. In MIT terms, this has been, I think, expressed by MIT's motto, which is mens et manus, brain and hands. It's what Americans think we ought to be doing. And that's a powerful part of the reason why manufacturing is and ought to be important to our country. So with government pouring huge new resources into the economy and closing off the border to many of the exports or imports that were getting in the past from China, there will certainly be more production in the United States. The big question is this. It's whether this expanded manufacturing will be any better at creating an economy that's more sustainable, more productive, and more equitable. If we just expand the kind of manufacturing that we have today, that would not be a good outcome. We would be reproducing all the current weaknesses of manufacturing simply on a larger scale. Economists already find that the tariffs and controls on Chinese imports have significantly raised the cost of goods for American households. In many cases today, we're seeing Chinese parts detouring via Vietnam and Mexico and arriving in the United States with higher prices because of this longer detour that they've made in getting to the United States. If we succeed in reshoring on any scale, if goods are made in the kind of production system that we have today in the United States, costs will be even higher for US consumers. If factories continue as they are today, they'll have even fewer applicants for jobs. The fact is that production jobs today are not well paid, even though they used to be in the past. In May 2022, so after COVID, the mean hourly production wage was $18.68, with an annual salary of $39,000. If we continue to manufacture as we do today, the negative impact on climate is going to continue. Manufacturing today generates 12% of our country's carbon emissions, and even more through the electricity that they use, generated by fossil fuels. And finally, if we continue the way we're going today, the very slow pace of adoption of new technology is not going to accelerate. In 2017, there were economists and Davos who predicted a devastating impact of robots on jobs. And they predicted that we were going to see this within 5 to 10 years. So a group of us from MIT started looking at average companies in Ohio, Arizona, and Massachusetts. When we went to look in these factories, we found 1 new robot purchase in Ohio, 3 new robot purchases in Arizona, and a couple in Massachusetts. By 2021, only 12% of all US factories had even one robot. And aside from auto assembly plants, most companies had only one robot. So the question is, if the robots are coming, they really better speed up here, but we don't know how to speed them up. And so this is really one of the most puzzling questions that we've come across in our research. Why is it that new technology has made so little progress in changing US manufacturing? So my conclusion from part one of my talk is if we, in fact, just expand what we're doing today, if that's all that all this money pouring into the system achieves, this would be a bad outcome. So what can we do, and what are we doing at MIT to tackle this problem? As you would expect, in individual labs and research groups, faculty are working on developing new technology. There are projects on artificial intelligence, there are projects on biomanufacturing, mining, additive, recycling batteries. What's exciting and new, I think, is that over the past year, there's a group of 15 faculty. Most of them are lab directors or center directors in engineering, but there's some social scientists like me. We've been meeting monthly to discuss how our work could contribute to a radical change in manufacturing. This group brings together engineers and social scientists. And in fact, this is a mode of collaboration that we've known here at MIT really since the 1990s, when we came together to produce a report that was called Made in America. And what we've been trying to focus on is this question of why new technology is so slow in making it into the real world. Each of us has some vision of what our work could contribute to new manufacturing. Each of us has some idea of what the challenges or the obstacles are to getting to this. And so we're trying to build research that can test our ideas and how to overcome these obstacles to getting new technology and new ways of working into the economy. Now, of course, if you ask somebody, why is it that their new technology is not being used today broadly, the answer you're most likely to get is that investors don't want to fund risky, hard tech projects, that risky, hard tech projects take a long time to come to market and to profitability. And that's certainly true, that there's a mismatch between investor preferences and the requirements of scaling up a new company. But I think, and our group has come to discover, that there are other equally important challenges. Consider the defense contractor who is reluctant to invest in a 3D printing machine because she knows how long it's going to take the government to qualify and certify the new part that she makes using additive. Or consider the supplier who employs 200 workers and has contracts with OEMs that are so short-term that he hesitates to buy a robot that might only be used on a few specific jobs, and those jobs ones that might disappear with the contract. Now, I think you can realize that some of these issues might be dealt with by new technology. For example, if you had robots that were easier to program and to reprogram, then you might not hesitate about buying one linked to a specific project. But other problems, other challenges require really different changes in supplier relations and government procurement. Some of these challenges will be specific to particular technologies, but we see obstacles that cut across all sectors. And I just want to mention a few of these obstacles and challenges for scaling up new manufacturing. They're the problems that I've called home alone. Home alone are all those problems that arise from the fact that the industrial ecosystem was basically ravaged by the loss of 6 million jobs over a period of about a decade, and of a lot of the manufacturing companies. What home alone means is the absence of those complementary capabilities that you need to bring a new industrial project to life. Let me give you an example. One of our researchers has a startup focused on rare earth magnets. And he's identified the rare earths. He has figured out the rare earth problem, the mining problem, but he's told us he can't find anyone in the United States that still knows how to make magnets. So that's a problem in the industrial ecosystem, that you can't find the complementary capabilities, those that you don't want to have to create yourself, but you hope to be able to deploy as part of your startups. Another challenge is identifying the right firm structure. Tesla today is the first new example of a vertically integrated firm. 40 years ago, all great American firms had such structures. IBM, DuPont, Motorola, all of these firms did everything from pretty fundamental research to manufacturing, to design, to manufacturing it, to selling it. All of those structures were destroyed by financial market pressures and the temptation to outsource and offshore. So what's the optimal company structure, firm structure for today's technologies? We need to look into this. This is essentially a new and open question. Yet another obstacle is the extremely slow pace of adoption. How could we accelerate that? Could we use defense procurement in a more strategic way? Could we actually ask the OEMs to pressure their suppliers to adopt new technology? Could we have the manufacturing extension program, which is the government's primary outreach to manufacturers? Could we have the manufacturing extension program shift its focus from promoting lean production to focus on technology adoption? Could we have the new manufacturing innovation institutes that were set up by the Obama administration? Could we have them actually work with some of these small and medium-sized companies, those that hire fewer than 500 people and that constitute 98% of the manufacturing companies? Could we ask them, please, to work with some of these smaller firms, as well as not only the larger firms? So we have an important research agenda, and we'd like to ask all of you for your help. And help, in this case, has a specific form. We want to understand what is possible in manufacturing today, how manufacturers who are operating on the frontier got there. So for those of you sitting in the room who do have companies, we'd like to visit your companies. We'd like to understand how you got to where you are. We'd like to be able to visit and understand how you overcame some of these challenges. And for those of you who are students, we would love to form teams and work with you and engage you in this research. And that's why I'm very pleased to introduce our panel for today, because these are leaders of manufacturing companies, and they represent manufacturing companies at every scale. I'm going to introduce them all now, and then they'll talk in order. So our first speaker is going to be Colin Cutts. Colin comes from a family-owned business. He's the vice president of G&T Manufacturing in Mentor, Ohio. They have a 20-person shop whose customers are forklifts, energy, defense, aerospace. My colleague, Ben Armstrong, the executive director of IPC, met Colin Cutts through Colin's involvement in something called Alliance for Working Together, which is an organization that brings together about 500 manufacturers in the Ohio area. And we'll hear from Colin how you can be an excellent new manufacturing company if you have 20 employees. Then we'll move to Mike Daly, who's Executive Vice President of Hypertherm, which is a 2,000-person manufacturing firm in New Hampshire with near Dartmouth, with offices in other parts of the country and also in Italy. He manages the company's supply chain. And what Hypertherm, he'll tell you about it, does is cutting and plasma systems, CNC motion, water jet cutting, and other exciting activities. And then finally, we'll hear from Christian Tünnes. Until last year, Christian was chairman of the board and CEO of DMG Mori in Germany. DMG Mori focuses on machine tools, on digital transformation, and automation. This year, Christian Tünnes is venturing into the world of manufacturing startups, an entirely different universe from German manufacturing, and we'll hear about his adventures in both realms. So thanks, and on to our speakers. Colin.
Hi, my name's Colin Cutts. I am the third generation at G&T Manufacturing. The company was put together by my grandfather and father back in 1978. They came to the United States. They worked at Rolls-Royce in England and came to the States with the idea that everything was bigger in America and they could be successful and generate a manufacturing company. We started off down on Train Avenue in a rental property. They had a couple manual machining centers, and they did some small work for a few design companies and a few design corporations in Ohio at that time. Their first major customer they picked up was Tow Motor, which is now known as Mitsubishi Caterpillar Forklifts of America. So they're now a large forklift manufacturing firm. They're located in Houston, Texas now. They're one of our largest customers outside of our defense work that we do. We moved into robotics and automation about 8 years ago to overcome the workforce headwinds that we were already seeing. We saw the headwinds coming long before COVID hit. We saw the headwinds long before we hit the recession that came in prior to COVID as things started to cool down in the housing market, and then COVID came and shut everything down. We'd already deployed robotics because we were struggling to find talented staff in the workforce that could help us with CNC machining and programming and to keep everything running and be able to be quality specialists on our floor. So what we ended up doing was we deployed our first robotic automation system 8 years ago, and we never looked back. After that, we are now 10 robots strong. We're a 20-man machine shop, so we have a 50% ratio robots to people. The 20 people spans across 2 shifts. We run 24/7, we run lights out, we let it run over the weekends. We truly let it run the automation, as someone would say, as Ford runs with 24/7. The only difference is their line's manned, they have engineers that are on board that are running everything and watching to oversee that everything's running correctly. We just have ourselves. It's just the 20 people on our team that run the robots and the automation. What this has allowed us to do is also hit this headwinds that everybody has seen in the past 5 years. This wage increase that keeps going up, and we keep seeing this minimum wage keeps getting lifted. Although minimum wage hasn't been lifted to the $15 an hour or $16 an hour that we see, and now the $20 an hour in California for fast food workers and everything, we overcame those headwinds by taking our team members on our staff, and we trained them how to work with the automation. So instead of deploying a robot and the robot does all of the work, we've now trained our staff on how to program, set up, and to utilize the robots and automation as a tool. So it's no longer a piece of equipment, it's actually a tool. It's like giving someone the correct wrench. If they need a 7/8 wrench, instead of giving them an adjustable wrench, you give them the 7/8 wrench. Now they're more efficient. They don't have to set the wrench to be able to tighten a bolt or tighten a nut up. By giving them the robot, they no longer now have to be in front of that machine, tending the machine continuously. We also onboarded all of our machines with Runshaw software and Runshaw probing. So now we backfeed the data out of our machining centers through machine metrics, and that allows us to backfeed that data back to the cloud, so we can now see, even right at this moment as I stand here, I can pull my cell phone out, I can pull machine metrics up, and I can see what my machines are doing currently, what tolerance bands we're holding, if something's faulting out, or if something's getting outside of its tolerance range. We've also set it up where we have our tool breakage detection and redundant tool systems set up, where that way then we can see that also via coming in through whether it's cloud-based like Google systems and items to get onto our control panel so we can see if a tool needs to be changed. Our newest integration that we put in, which is our 10th robotic system, we put a Murata machining center in, and we have a twin spindle machining center, and we've taken a part that's for the medical industry. It's proprietary. I can't share too much about it really, but the shape of the part changes part to part every single time. So when we introduce the part, we introduce a variable chart that allows us then to manufacture the part by using variables only in the program. And we automated this by unloading and loading. So the term, and I was joking with some of the people from MIT last night when I saw them, we literally have a machine that is making snowflakes in manufacturing at this time because the variables change every single time as we go forward and we make the parts. So our success in robotics and automation has allowed us to keep our wages traditionally a lot higher than locally. I know when you get off the exit in Menor, there's a McDonald's there, it's $16 an hour. Doesn't matter what minimum wage is. Minimum wage in Menor, Ohio is $16 an hour because that's what you can get at McDonald's. By putting the automation in, this has allowed us to keep our wages up to where we're in the neighborhood now where our average wage at G&T right now, we're paying around $52,000 a year without benefits for our employees currently. So it works out to about $26 an hour. And we've kept that through the automation and allowing our workforce to be trained in the automation, whether internally or through AWT programs locally. So that's my part for us on automation.
Good morning. My name is Mike Daly, and thank you very much for the nice introduction earlier. I represent Hypertherm Associates. We're roughly 1,900 associate, fully 100% employee-owned company headquartered in Hanover, New Hampshire. As was mentioned, we have operations in Seattle, Washington, a large operation up in New Hampshire, and we have sales offices all over the world distributing and selling our products. I thought about how to talk about Hypertherm today in our journey, and maybe it is a chronological would be the best. I joined Hypertherm in 2007, but really back, actually Hypertherm started in 1968, an offshoot of a PhD project in research at Thayer School of Engineering at Dartmouth College. Our founder, Dick Couch, moved across the street in a small garage, and the rest is sort of history, but we're in our 56th year now. But really, fits and starts growing the company through the 1990s. And the year 2000 hit, and we actually had a very, very strong product, plasma cutting equipment product that launched at the same time as the infrastructure build in China really started to consume our type of equipment. So a lot of infrastructure build, shipbuilding, road building, construction, and so on. So we hit at the perfect time with the perfect product. And our sales skyrocketed and we could not keep up. We were adding equipment haphazardly. We were bringing people in. We were seeing turnover. And we started in the early 2000s with a program of lean manufacturing. And it's a version of lean manufacturing coupled with theory of constraints that really worked well for us. So zero waste is a great concept, but inventory is a great concept as well in the right places. So we really married the two and really developed what we call lean principles and standards, 10 key principles that we guide all of our operations with. And whether it's an assembly operation, a machining operation, it doesn't matter. Those are the key principles that how we want to run our operation. We can talk about that more later. And we took the first sort of 10 years of the 2000s developing our lean manufacturing strategy, but we still had turnover in our people. We were growing 20% year on year for about a 6 or 7 year period, and we were hiring and losing people very, very quickly. In 2006, we're in Hanover, New Hampshire, not a lot of community college system up that way. So we started our own Hypertherm Technical Training Institute to develop new CNC machine operators. So we took absolutely green people from all walks of life into our training institute for a 9-week period and taught them shop math, key concepts for CNC machining. We had several machine tools dedicated to training only at a separate building. And we took them through the fundamentals for 9 weeks so they could hit our production floors ready to contribute on that first day. And we paid them during those 9 weeks in cooperation with the Department of Labor grant. So we're 18 years into that process. We've trained over 900 associates. More than half of those people over the last 18 years are still at Hypertherm, either as a machine operator or they've grown up through the organization. Many of them are in manufacturing management now. So a fantastic story. So that was the early and late 2000s. After the Great Recession, we found that we couldn't continue to add people. So we started thinking about automation and robotics, as Colin spoke about, and had a very aggressive program of developing new systems integrated with our machine tools. We added some of our first robots around 2010. And at the time, they were very large, very expensive, very intricate cells, integrated coordinate measuring machines, feedback to the machines, and so on. And we got great value from that. But one of the learnings from some of those very early expensive automation projects was a lot of the value was in very simple automation. So now a lot of the automation that we're investing in at Hypertherm, in a lot of cases, is very simple pick and place machines, machine tending and things like that, where the payback is a year to 18 months to 2 years. And because we have several hundred machine tools, once we have a solution, we can replicate very quickly and get that benefit very quickly. So we're sort of learning on the fly. We work with robotic integrators, so third parties, but we also have an in-house automation team developing custom equipment for specific operations that we have. So we have some very sort of intricate consumable parts that we manufacture and sell to our installed base of systems out in the world. So we've got that in-house capability as well. It's one thing to put a robot in place and put a cell in place. It's another thing to support it day in and day out. So that Hypertherm Technical Training Institute that I spoke of, we're still doing CNC fundamentals, but we've added process technician development classes to develop those people that can actually troubleshoot, maintain, work with operators to make sure that uptime continues for us. And then with the Great Recession, we're really now focused on how do we get insights from our equipment. So like Colin mentioned, we're also pulling information from our equipment through machine metrics and trying to get great insights and make better investment decisions. Where do we have extra capacity? Where do we have excessive downtime? And really taking corrective actions there. So I'll stop there and can take questions later. Thank you.
Thank you.
Yeah, my name is Christian Tönnes. I've been 25 years confronted with manufacturing. Out of the 25 years I worked the whole time with a company called DMG Mori. The beauty was we built machine tools, which were pretty much at the beginning of a process chain. And this gave me the chance to visit 50 different branches and thousands of customers. I want to say, first of all, refer to what you said, turning point. I think there's a turning point in manufacturing. I think there's nobody in the room, but also not outside of the room, who does not believe in manufacturing. I believe that the biggest problems we have can only be solved by engineers. I'm not an engineer, even though I was responsible for R&D 7 years and chairman 7 years, because I always put the finger in the right hole and had respect for engineers and listened, even though I'm not the best listener. But what I'm saying is that I believe manufacturing is key. And we have to question what is new manufacturing. For me, it's very easy. For me, new manufacturing means you do more with less. What does that mean? This means that we have to think about technology integration. Really, real innovation comes from product and process innovation. I think there was a big mistake done that product development were done in the US, but a lot of production done in China. You mentioned Tesla with a vertical integration approach. I think you need to not necessarily do everything yourself, but you need to control the complete process chain like Apple. And best, if you can finance, you have to be vertically integrated. And I think with the CNC were developed at MIT, beautiful new additive technologies come here from MIT, Media Lab, and all these nice, beautiful institutions you have here. And one of the reasons MIT is so strong, because you don't have these hierarchies. You are humble, you're hardworking, you have driving force, and you are flat. So I think if companies, big companies, and my company had 4 billion revenues and for 15,000 people, mean in former times, is also to become more flat, to also think more outside in. I always quote and say to my people in Germany and also my people in the group, I said, the heart of manufacturing is in Germany, maybe Japan, but in the US, they are platform-based. Chinese have talent. So if we don't step out of the comfort zone and continue and don't think outside in and don't think new, we will end up rough and rusty. And I believe that there are beautiful examples how to move technology. I have 5 minutes left. So technology can be more integrated and also transferred back to the US. One example is he's a co-founder of a beautiful company which I love. It's called Vulcanforms. They build an additive technology and they do it in metal and they are able to scale. They are clever enough not to sell the machines, so they just sell their performance. But what they do is they are able to substitute several production steps and do this with less and do this in one. So they are strong in medical, they are strong in aerospace. I think also everybody knows that mobiles and watches are done in China. Why? Because they scale through people. And you have hundreds of robo-drills or machining centers from Fanuc or whatever in Shenzhen. I saw it myself. But is this the future? The biggest problem in manufacturing means manpower. So how can you overcome? The answer is technology. The first step is technology, and I like the approach that with beautiful defense support, you are driving the industry. But still, you need technology integration, and then you need also to involve the people. And I believe that you can do this with a factor 1 to 1,000. Instead of having 100,000 of robo-drill, they take the powder, and I always call you TSMC for manufacturing, and you can do mobiles also with 1,000th of the space, or watches. Another example, for instance, is pharma, as we are having here now the center worldwide for pharma, and John and me, we had this talk. I believe Boston can be also, with your beautiful knowledge also, and this is the reason I'm spending so much time now in Boston, is first of all, I said I have to step out of the comfort zone myself. That was the reason after 25 years I wanted to do something new because I turned 50. And the second thing is where to go. For me, Boston was a perfect place, and I believe you can be here also the world center for manufacturing, because you are having the right people, you're having the right approach, and I think US is much better positioned now than 5 or 10 years ago. If you are a corporate and ask where you would invest definitely in the US. And one example, at the moment, you would not invest in Europe, you would not invest in China, you would invest in the US. And you're right, we need to involve the people. It's not only the answer first is technology, the second answer is to involve people. But I wanted to give this example also, in addition to Vulcanforms and additive metal, I wanted to speak about pharma. 80% of ingredients are also done in China. 80% of pharma products are done with batch production. But with additive technology, you can do chemistry in motion, you can do chemistry in flow. I invested in a company myself, I'm a little bit doing here advertisement, also because we are looking for young, good people, where you building reactors, and with additive technology, you can have a microfab, whereas in the past, you need huge companies. Another example where you have a factor of 1 to 1,000 and where things can be done home turf here. And last, when we speak so much about technology and technology integration, how to involve the people. You need to involve the people by giving them the chance to also use data, use new technology, and have to make this investment step. And I don't believe alone in people from the financing business. Neither lawyers nor bankers are making the race. It needs to be engineers. So enable the people, give them something. And there's another beautiful example coming from Media Lab here also where, which is called TULIP, where they enable manufacturers to work with data and do it themselves. This is a key. Manufacturing is not only having the problem that the biggest problem is manpower, it's also a bottom-up approach needed. You cannot do a top-down approach. You need to involve the people on the front line and who are doing the job. So give them the chance, give them the opportunity, give them the equipment, put them in the frame, and then let them experience. And then you will see America will be stronger, will be back in manufacturing, but it doesn't matter if it's in America or India or China. Things with our climate crisis, which is the biggest problem, have to become more local and have to do more with less. So good luck. You are honored to work and be here at this beautiful institute. And I'm also honored, Jen. John, thank you. Suzanne, thank you. All the best to all of you. Thank you.
So we have some time for questions. Is there somebody who has a question? Yes.
Hi, I know one of the big things you were talking about with this new manufacturing was getting more people actually back into manufacturing, but at the same time also involving a lot of robotics. So I was wondering how you were planning on getting people back into manufacturing when at the same time they may have that worry that they'll get outsourced by robots when they get back into it.
Yeah, I mean, imagine that you're the parent of a kid who is, who likes working with his hands and seems kind of interested in playing around with materials. Would you actually, if you as a parent knew that 6 million jobs have been lost in manufacturing, how would you think about your kid going off and working in manufacturing? How would you think about it if you knew that your child was going to earn more or less the same amount of money as he might earn going to work at Walmart's? So I think the problem is not that people are not interested, and people, I think, really like manufacturing. I mean, they're interested, but I think we need to do something first about getting wages up there. And manufacturing wages used to be higher relative to the economy, but then they've kind of fallen off over time. And and I think that people have to see in companies that there are solutions. And I think each one of these company presentations has shown us people working with robots. None of them have reduced the number of people. They've basically figured out how robots can complement human effort. So I think your question is exactly a good one. Yes.
So my question is, was a comment you made earlier.
I can.
A comment you made earlier about the risky go-to-market strategy or timing for hard tech. So we can't do all the improvements we want to make with software alone. We absolutely have to have hard tech. How do we reduce some of those barriers and of adoption and actually get that done and spend that money? Because your capital investment ROI is going to be, what, 10 years or something? How do we make improvements in that so we can actually have hard tech to physically make improvements as well as software and workforce development?
I think this is just a huge question, and I don't think there are any easy answers here for more rapid adoption. I myself think that we should use some of the levers that we already have in the system. And one big lever is procurement. And I think that if the Defense Department required that the OEMs that they work with would actually play a larger role in getting their suppliers to adopt new equipment. I mean, when I visited a firm in Ohio, and the firm said that they had some small defense contract that built up to something kind of interesting with the Navy. And the Navy said to them, we want robotic welding. It makes better seams. So the company bought a welding robot. And then there was the big question, well, who knows how to use the welding robot? And so then they actually looked around at the community colleges, and it turned out community colleges were teaching robots. And at that point, they hired one of these new employees who had actually taken the class. Whereas very often, the problem is simply that when you suggest to manufacturers that they might be hiring some of these people coming out of the classes, people say, well, you know, why do I want a guy who's taken a class on robots or additive? I don't have a 3D printer. I don't have any robots. I want someone who can work on the machines I have. So I visited that particular guy's shop, plant. I mean, he has hundreds of workers. And what was he using? His milling machines, many of them were Davenports that his grandfather had purchased in the 1940s. Well, he said he wants people to work on the machines he has. Well, we're not about to start educating people to work on 1940s milling machines. So that's why I think we really need to get new technology into the shops, both because that will be more exciting for the for new workforce, but also that can push change all across the line. Just one idea.
Right, thank you.
So I have a question. I want to build on what you're saying, Suzanne, but I have a question actually for Colin and for Mike. One of the things that we were talking about when we talk about new manufacturing is the importance of people. So I'm curious as to, we have some workforce development programs happening here at MIT, but I'm curious as to what you think the role that manufacturing companies play in a workforce development.
So in Ohio, we have a really large benefit right now. Ohio is really structured now to push back towards manufacturing. They realized that that's what was in Ohio. We were basically what they call it, the Rust Belt, they always say. We're in part of that area of manufacturing. There's huge manufacturers that were in Ohio. And Ohio started to invest back in with what they call tech cred. So we can take our members on our shop floor and we can put them through programs like at AWT, Lakeland Community College, Cleveland State, and they'll reimburse us through tax credits to upskill our workforce as long as we can hit an accredited program that they're looking for workforce development. So that's kind of helped us in the small microcosm of Ohio. I don't know if it's happening in other states, but in Ohio, that's really been a great venture for us.
Yes.
So I actually want to piggyback on that as well and kind of riff off of what you said. You were talking about, a parent encouraging their child. And this is directed, gentlemen, at all three of you. So I am a parent. I'm a father of 6. And my youngest daughter wants to come to MIT, which will probably involve selling one of the other children, but that's, that's an aside. My two oldest sons, one's a blacksmith, the other one's in construction, both of whom would be excellent in the manufacturing arena from a career standpoint. The problem, as I see it, is from an education standpoint. The youngest daughter, MIT, she's going to be an engineer. She's going to be incredibly successful. I'm already proud of her, and she hasn't broken out of middle school yet. But the older kids, right, even the tech schools today really aren't designed to feed their graduates into manufacturing, right? They're still on the base trades, which is great because we also have a shortage there. But, fundamentally, before you can get to retraining some of your employees using the benefits that you have in Ohio, we have to do something about the employee base, right? We have a vast shortage. So we have to do something about fundamentally changing the educational system. And if we go to the bottom-up approach that this gentleman had mentioned, really then it becomes the responsibility of manufacturing to help influence the educational change that's going to be necessary to feed their own employee needs over the next couple of decades. If we don't do that, manufacturing is going to die on the vine, right? You hear about the gray tsunami. All of your really experienced people are retiring out right now, and they're taking huge amounts of institutional knowledge with them, right? So How would you gentlemen each address manufacturing's responsibility to building the future of their own workforce?
So, oh, yeah.
Okay. First of all,
Christian.
I believe a lot in involving young people. In Germany, we have these apprenticeship programs. Secondary, when I compare leading companies in manufacturing to non-leading, like you said, Davenport, and a company in manufacturing who is in a leading position looks like a pharma company, looks like medical. When I'm visiting companies sometimes around the world, you can see young dirt and bad dirt, but you can, if you go in a modern environment, you don't want to work in it's in an environment where everything is dirty and it looks like a foundry. Yeah, so this is something